Welcome to interview questions on statistics. Today's question is, what is an outlier and how do you detect them? So first of all, let's see what is an outlier. So basically, outliers are those data points which are generally away from your normal range of data. So let's say we have a proper data set and you have a column or you have a feature which contains a data, for example, let's say age. So you have your normal range of age like between 30 to 40 or 30 to 80. And suddenly out of nowhere, you see certain ages like 200, 300. So those kind of data points, they are nothing but your outliers. So they are always away from your rest of your observation or your normal range of data. Now, what is the significance of these outliers basically? So generally, because of the presence of these outliers, it actually affects the way your algorithm learns the relation between your independent and dependent variable. So if your independent features have outliers, so that actually affects the learning process of the algorithm. And this will actually result in your algorithm not properly learning the relationship. So it might not do the predictions correctly because of this reason. And secondly, obviously, because of that effect in the learning process, your algorithm will perform really bad, or you could say there will be a significantly less performance with the model. So yes, outliers really do affect your algorithm in all the way. And generally, there are ways to actually detect the outliers. So one of the easiest way would be your box plots, which you have in your visualization or in your and data analysis part. But we have two specific methods which can actually detect the outliers as well as handle them as well. So they are interquartile range and empirical rule, or also called as three standard deviation method. So your interquartile range is nothing but the middle half of the data. So it's the 50% of the data, or we call it as the range between first quartile and third quartile of the data. So that is your IQR range. And using that, we generally find your upper limit and lower limit. So anything beyond the upper limit or before the lower limit will be nothing but outliers. Similarly, for empirical rule, we generally consider this for a normal distribution. So if your distribution is normal, we use the empirical rule where we have the data between or distributed between three standard deviations from the mean. So if your outliers or if your data points which are away from three standard deviations, either on the positive side or on the negative side, we call those data points as outliers. So these two methods are the best way to actually identify the outliers. So next question, in what situation is median more essential than the mean? So basically, in certain situations, we generally consider median more than mean. And one of the reason is because of the outliers. So outliers generally affect the way your data distribution looks like. So because of those outliers, maybe the data may not be normal. So generally we say that if the data is normal, we usually consider the mean as the best parametric method. Or you could say if the data is distorted in some way, like let's say it has some skewness or it has some kurtosis. So that can actually happen because of the presence of outliers. So because of that, we generally consider the median, because when there is skewness, let's say either on positive side or on negative side, the mean, median, mode, all the three will be obviously different because the distribution is not a normal distribution anymore. So in that kind of situation, we consider median as the best option. So we prefer median in those kind of situations, specifically when there are outliers present in the data. So as an example for your outliers, let's just assume we have a scatter plot or something. So we distributed the data, two features. Let's say this is X and Y. Now let's say this is your normal range of data. This is where most of your data is concentrated. And then suddenly out of nowhere, you might have some data away from the range. like this. Like they're not part of your normal range. So they could potentially be an outlier. So we wouldn't know if they're actually outliers unless and until we actually use one of this IQR or three standard deviation method. So in short, if I have to say, the IQR would be, let's say, if this is your distribution of the data, and your IQR is usually the 50% of the data or the middle half of the data. This region will be your IQR. So it contains 50% of your data. On the other hand, your empirical role is generally more helpful if your data is normally distributed. So let's say this is a normally distributed data. So we divide the whole data into three standard deviations from the mean in this form, just as an example. So this will be your mean, and this is one standard deviation, two standard deviation, and three standard deviation on both positive as well as negative side. So when it comes to IQR, if you find any data points away from the upper limit, so this is your upper limit, this is your lower limit. So if you find any outliers away from those limits, they are nothing but your outliers. Same way for empirical rule. If you find any data points which are away from positive side standard three standard deviations as well as the negative side away from three standard deviation, those are nothing but your outliers. And generally, because of the presence of the outliers, we do not consider mean as the best method. We use the median, and median would be the obvious choice if you have outliers in your data. And obviously, the outliers are generally going to cause distortion in your data, so the data will not be normal.